Alright, in this video we are going to look at weekly challenge 3 from AppMillers community, which is called add two numbers. Now this is the second question from the LeetCode. Now here the problem statement says that you are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order and each of their nodes contains a single digit. So this means that in the linked list, in each node we will have the digits and the whole number is in reverse order. And we need to add these two numbers and return the sum as linked list. And here the assumption is two numbers do not contain any leading zero except the number 0 itself. Now let's look at this in the example to understand the problem statement. So here we have first linked list. Now if you look at this linked list, we can easily see that in each node we have one digit, and this is a number in reverse order. So this means that in this linked list we have 352. Because if we read this linked list in reverse order, you will see that the first number is 3, then 5, then 2. Now if we combine them together, it's going to be 352. Then, as the problem statement says, we have two linked lists. Now we'll look at the second linked list. So here again, in each node we have one digit. So this is going to be 401. So if you read this linked list in reverse order, it's going to be 401. Now if we sum up these two numbers, the result is going to be 753. Now after getting this result, we need to return the linked list. In each node we have the digits of this number, and this is going to be also in reverse order. So if you read this number in reverse order, first number is 7, then 5, then 3, and this is going to be 753. Now to make things clear, let's look at the second example. So let's say as a first linked list we have 2, 4, 3 in each node, and if you write it in reverse order, it's going to be 342. Then we have the second linked list, in this case 465. Now if we sum up them, it's going to be 807. So this means that the result linked list is going to be like this. So we are writing the numbers in reverse order, and in each node we have one digit. Now if you look at over here, you can easily see that 4 plus 6 is 10, and we wrote over here 0 and carried 1 to the next digit. So we need to take into account this one as well. Now let's look at more complex example. So let's say as a first linked list we have something like this, which includes 4 9s. If you read it in order or in reverse order, the number is not changed. And let's say we have another linked list like this, which includes 3 9s. Now if we sum up them, it's going to be 10,998. And we need to put this one in the linked list like this in reverse order. So the output linked list is going to be like this. So with these examples, hopefully everything is clear about the problem statement. Now let's look at the solution in Python. So here, first we are going to create the class for the node. So this is a node class that comes from the linked list. So we know that in case of linked list, for the simplest node, we will have the class name. Then it's going to take as a parameter value and the next reference. So here self shows that this method is a part of class. So whenever we create an object using this class, it's going to call first init method. So by default, it's going to take as a parameter for value 0, and the next node is going to be none. So we have the properties of value and next, which takes the values that we pass as a parameter over here. So we are going to use this list node and create the linked list and pass it that as a parameter to the function that we are going to create. So the function for adding these two linked lists is going to be like this. So we are just going to go through this function and explain everything in detail. And we are going to do the dry run over here, what happens in the memory whenever we run this function. So let's say we start to execute this function. So in this case, as you can see, this function takes as a parameter two linked lists, which is a type of list node, and it's returning the linked list. So this means that when we run this function, we are going to pass these two linked lists to this function. So L1, which points to the first node, and L2 also points to the second linked list first node currently. So L1 and L2 over here are the head nodes of the linked list that's going to be added together. So in the next line, we are creating the dummy head for resulting linked list. So this simplifies the managing the head of the linked list and makes the appending new nodes easier without special condition. So whenever this line of code executed in the memory, it's going to create a new node which is going to be the value of 0 and it's not pointing to anything, and dummy head points to this new node. Then we are going to go ahead and create the tail pointer to track the current node in the result list as it is built. So currently it's going to point to the dummy head as this line executed over here. Then we have created a variable which is going to initialize to 0. So this variable which is going to store the carryover value from summing up the two digits. For example, if we sum up 9 plus 8, we need to put in the carry 1. But currently it's going to be 0. Then we have a loop like this. So this loop will run as long as there are digits left to process in either L1 or L2, or there is a non-zero carry. So this ensures that we have handled all cases. So then we have created digit 1 variable which is going to retrieve the value of the current node in L1, or it's going to be 0 if L1 has been fully traversed. So in this case we see that L1 points to the first node of the first linked list. So this means that when we execute this line now, it's going to be 2. Now similarly, we have created digit 2 variable for second linked list. So here again, when we run this, it's going to be 5 because currently L2 points to the first node of the second linked list. Then we are going to calculate the sum. So this is going to compute the total sum of two digits and the carry. So in our case, carry is 0, digit 1 is 2, and digit 2 is 5. So sum is going to be 7. Then we are going to calculate the digit itself. So this is going to extract the least significant digit of the sum, the digit to store in the current node. So it's going to be sum module 10, which is going to take the remainder. So 7 divided by 10, the remainder is going to be 7. Then in the next line, we are going to calculate the carry. So when we calculate the carry, we are dividing the sum with 10 and taking the floor. So in this case, carry remains 0 because 7 divided by 10, so the floor value is going to be 0. Then we are going to go ahead and create the new node. So the new node will be created with the digit to represent the current place in the result. So when we execute this line of code, this is what happens in the memory. So new node points to the node with the value of 70 and it points to the null. Then we are going to append the new node to the dummy head that we have created over here. Now to be able to do that, we are going to access the tail.next, which is going to be this reference, points to this new node. So this is going to happen in the next line. So we are writing tail.next, which is this part, points to this new node. Then after doing so, we have to move the tail. So tail will move to the next node. So tail.next is going to be this new node. So tail will point to this new node. So after doing so, we are going to move these pointers to the next node. So in this case, L1 is going to be L1.next. So if there is a value, it's going to be L1.next. If there is not, it's going to point to none. So in our case, there is a next node over here. So it's going to move to the next node. So same thing applicable for L2 also. So it's going to move to the next node. So after first iteration, this is what will happen in the memory. Then we are going to continue to the next iteration. So one more time here again, we are going to check that if L1 is not none, or L2 is not none, or carry is not equal to 0. So in our case, in the first condition, we see that L1 is not none. So that's why it's going to continue to the inside this loop. So here we are going to take the digit 1, which is going to be 4. Then we will continue to take the digit 2, which is going to be 6 because L2 points to the 6. Then we are going to calculate the sum. This means that we are going to sum up everything together. So it's going to be 10 in this case because 0 plus 4 plus 6 is 10. Then we are going to go to the next line. In the next line, we are calculating the digit, which is going to be 0 because the remainder of the 10 divided by 10 is going to be 0. Then we'll calculate the carry because when we divide 10 by 10 is going to be 1. So the carry is going to be 1 because 6 plus 4 is 10. So we need to write 0 and move the 1 to carry over. Then we are going to create a new node with this new digit. So new digit is 0. So new node will be created like this. Then we are going to append this new node to the dummy head result linked list that we have created over here. So in this case, we have to append it after the second node. So tail points to the second node. So if we write tail.next points to the new node, it's going to append it to this linked list. Then we are going to move the tail to the next node, so it's going to be like this. So tail points to the 0. Then we are going to move L1 and L2. So L1 will point to the last node in the first linked list, and L2 will point to the last node in the second linked list. Then we will continue one more time to this while loop. So here we can easily see that L1 is not none, so it's going to execute this while loop. So here the digit 1 is 3, digit 2 is going to be 4, then sum is going to be 1 plus 3 plus 4 is going to be 8. Then we will calculate digit, so digit is going to be 8 because 8 divided by 10 is going to be 0 and the remainder is 8. Then we are going to calculate carry, so in our case carry is going to be 0. Then we are going to create new node with this digit. So the digit is going to be 8 and new node points to this node with the value of 8. Then we need to append this node to this linked list that we have created over here, which is going to be the result linked list. So to be able to do that, we are accessing the tail.next and points to the new node. So this is going to create a reference between the last node and this new node. Then we are going to move tail to this new node. Then we are going to move L1 and L2. So we see that after this node we don't have any node, so that's why it's going to be none. Then for L2 also this is applicable. L2 will point to the none. Then we are going to execute the while loop one more time. So here we can easily see that L1 is none and L2 is none and the carry was 0. So this means that this loop will be stopped over here and it's going to continue to the result variable that we need to create over here. So we have created dummy head over here, so we don't need this part. So that's why in the result we are just going to put result is equal to dummy head.next, which is going to be the first node that we have over here, which is 7. Then we need to delete the link from dummy head to this node. So that's why we are going to put dummy head.next is equal to none. So this is going to be deleted from the memory. Then at the end we're just going to return the result. So as you can see with these steps, we have got the linked list, which is the sum of two linked lists that we have passed over here, and as a result we have put it in reverse order. So hopefully with this you have understood how we are solving add two numbers problem, which is a second question in LeetCode. Now we can go ahead and check this in practice and see what is the time and space complexity for this. Alright, I've put whole code over here to check how this is working. So this is the list node class. Then we have put the add two numbers function itself that we have discussed. And I have created helper functions over here, which is creating the linked list based on the values that we are passing over here. Basically, values parameter is a list over here. So based on number of the elements in the list, it's going to create the node and reference these nodes to each other, and at the end it's going to return the linked list. Then we have another helper function over here which is printing the linked list itself. First we are creating L1 based on this list in which we have 2, 4, 3, and we are creating the second linked list based on these numbers, which is representing 342 and 465. Now if we run this function for this L1 and L2 and print out result to the console, we are going to get this number, which is the reverse form of 807. Now this is how this function works. Now let's look at the time and space complexity for add two numbers function. So the time complexity of two numbers function depends on the number of the nodes in the L1 and L2. So in the worst case, we traverse through every node of both linked lists. So let's say n is the number of the elements in L1 and m is the number of the elements in L2. So the loop will run with the maximum number between these numbers. So if m is greater than n, it's going to be run m numbers, or if n is greater than m, it's going to run n numbers. So that's why we are going to put maximum nm, because it continues until both lists are fully processed and any remaining carry is handled. So this means that the time complexity is going to be O maximum nm. So when it comes to the space complexity, we know that a new linked list is created for the result. So the number of the elements in the linked list equals the maximum length of the L1 and L2. So this means that here again, the space complexity is going to be O maximum nm, because in the result linked list, we will have this number of the elements. So this function does not use any recursive calls or additional data structures, so no extra space required beyond the new linked list. So that's why overall space complexity is going to be O maximum nm. So hopefully everything is clear.